I'm sure most people think that we live on a spinning ball flying through space. If you give me 1 minute, I'll show you that it's not possible. I have to do it within 1 minute because you know how people are. Squirrel! We all have a short attention span nowadays, so I'm going to show you how the sun's path disproves the globe. Okay, let's check out the sun's path. Okay, so it follows this line on the way up, and it follows a line on the way down. So in this case, the sun made a pyramid, and that disproves the globe model. So there you go. I disproved the globe in 45 seconds. Let me explain to you why. Okay, so here's the globe model. Now the sun is 93 million miles away, and it makes a 93 million mile arc. So the sun has to make an arc. The earth spins forward, causing the sun to rise, and it has to rise in an arc. But that's not what we see in reality. Simple. Now if you stay with me a little longer, I'll show you how the path of the sun makes total sense on a flat earth. Okay, here's the new standard map of the world. As it is. I guess it's the old standard map now. And here we go. Patented, 1892. Okay, on the map I drew a red line here, which is the winter solstice. That's the path of the sun in the wintertime. And the inner line right here is the summer solstice. That's the path of the sun in the summertime. And that's how you get your seasons. And the map shows you right here. Here's your winter solstice, Tropic of Capricorn. And here's your summer solstice, tighter circle, Tropic of Cancer. So that's how the seasons work on a flat Earth. Okay, here's a full day time lapse from Fairbanks, Alaska. So it comes up on an angle, and then it goes flat across the trees for 2 hours. And then it goes back down on an angle straight. So there is no arc. And let me show you why it's doing that. According to the geocentric model, the sun rises and sets due to perspective. So in the summertime, the sun is doing a tight circle on the summer solstice. And then 6 months later, it's on the equator. And then 6 months later, now it's on the winter solstice line. So here's Fairbanks, Alaska, and it was taken on this video was taken on the winter solstice. So I did the math, and you can actually see the sun for 3 hours. These are the two black marks right here. So the sun is following the winter solstice, and it gets to about here, and it starts to light up Fairbanks. And then it gets to here on that line, and you can actually see the sun. And then a half hour later, it hits the top of the trees. And then it runs the top of the trees flat for 2 hours. And then it takes a half hour to hit the set, and then the sun fades away. So it makes total sense on the geocentric model. There is no arc in the sun. Check out this sunrise on the summer solstice in Sweden. Look at this. It's an anti-arc or a reverse arc. How's that possible on a globe? Okay, using this distance that we established the sun from Fairbanks, now let's use it in Sweden. So your viewing angle is going to be this radius right here. Okay, so here's Stockholm, Sweden, a little tack. Now the sun is on the summer solstice, on the inner circle. So the sun is coming around. As soon as it gets about here, Stockholm starts to light up. As soon as it gets about here, you can actually see the sun. And then it kind of sweeps at you. It sweeps like real close to you. A lot closer to you than over here where the sun stays the same distance from you. And that's why you get a flat spot on top. This one, it sweeps around and it starts coming at you, and it makes an anti-arc or a reverse arc. That's not going to happen on a globe. And it totally matches. Makes sense. Let's take a look at it again a little faster. Watch it sweep around. That's awesome. Okay, let's check out a sunset from Norway. So here's the path of the sun, and here's Norway, and here's our radius of view. So the sun's going to come sweeping around like this, and it's going to set right there. So it's going to curve around this way. Let's see if it matches reality. I think it matches pretty well, and it makes a reverse arc again. Okay, let's go back to the original time lapse I showed you. This is from Bristol, UK. Now it makes a pyramid. You can see there's a few hours missing in the middle here. And let me show you why it makes a pyramid. It's because the sun is moving across the sky, and because of perspective, it rises and sets, and it makes a pyramid. Just like these telephone poles. The railroad tracks are flat, and the telephone poles crash to the ground due to perspective. Okay, here's the sun. Now my hand is the globe, is the earth. Now the sun goes around the earth. Either the sun's going around the earth or my hand is spinning. It's still going to make an arc. In all the time lapses that we looked at, there isn't any of them that have an arc. So I'm going to go with we don't live on a globe. One last tidbit. Here's the Arctic. The reason why they call it the Arctic, because the sun arcs around it. And this right here is the Antarctic, because the sun antarcs, or reverse arcs around it. Yeah.